So hello everyone, hope all of you are doing very well. Today we are going to discuss a very fundamental and interesting topic. So as you know, we have discussed some regression models that are just like linear regression. Then we also discuss on polynomial regression. So in linear regression, we discuss on two types of regression model. One is simple and another was multiple. But the question is, when we apply those model, then how to check which model gives best prediction. How do we approach this type of questions? So that means we have to know what is the matrix which gives the which can measure the prediction of a model. So now, so today in today's lecture, we will discuss on that topic. So our today's our agenda will be some performance metric of regression, their definition, formula, visualization, and in last step we will show the code which is in Python. How do we write this things? So first, what are the performance metrics for the regression? So there are basically two types of performance metrics we generally use. So performance performance metrics for regression. First one is R squared. Sometimes we also call it as R2 score. And second is adjusted R squared or adjusted R2 score. So first, just write the definition of R2 score. So R squared is nothing but 1 minus sum of square residual by sum of square total. So what is sum of square residual and what is sum of square total? We just try to find that. So let's start with an image. So let's say this is x-axis and this is y-axis, and these are the data sets we have with that. So in regression, we generally try to find a line which can gives the prediction for future x. That means if we put some x, it gives the values of y. So if this is our prediction line, prediction curve or line, then we calculate the error. We generally calculate the error. Then how do we calculate the error? We just take the difference of this difference to find the error. So from there we can calculate this sum of square residual. How do we calculate? We calculate how do we calculate? Let's say we have a n number of data points. Then the error will be yi minus yi at square, where yi is actual value and yi hat is predicted value. And I goes to 1 to n number of data points in the data sets. This is will be the our sum of square residual. Then what will be the sum of square total? So to find this, first we have to know the mean of y, mean of yi. So we denote it as y bar. This is nothing but mean value of yi. So yi as you see here, that this is the yi, these are yi. So the value will be here, or it's here, and here also. So let's say this is y bar. Then we draw a line from this y bar point and take difference from these points. So this difference we can write as summation of I equal to 1 to n yi minus y bar whole square. This is gives sum of square total. So as you see here, so our r square formula is nothing but 1 by sum of square residual by sum of square total. So then we can clearly conclude that it gives it's the range of r square will be 0 to 1. We clearly conclude that here, because this will be always now. What is adjusted r square? It's actually modification version of the r square. Because why we use this adjusted r square instead of r, we will discuss using some note which I have write down here. So The adjusted R square is, the formula is 1 minus 1 R square into n minus 1 by n minus p minus 1. So where n is number of data point, p is number of independent variable in the data point in the data set, and R square is R2 score, which we can calculate as 1 minus sum of square residual by sum of square total. So let's go to the our code, and we also discuss there the description of these tools and their differences. So as I explained R square and adjusted R square in previous, here I have made one GitHub file, which I will upload it in the description section. So here I put all the definition uh, which I discussed in previous, and there is R square. This is the adjusted R square definition. Now we just go to the, if you need more details, so you have to read this or you have to read this file. So now we try to discuss the difference between R square, the adjusted R square. So as you see here, the calculation part, up to the calculation part we have already discussed. So here the formula is R square equal to 1 minus sum of square residual by sum of square total. Here the adjusted R square equal 1 minus 1 by R square into n minus 1 by n minus p minus 1. Or here it is the total number of data points in our data sets, and p is the number of independent variable. So I will explain by one very popular data sets, which is called California data sets. So we will see that uh, in some time. So here the interpretation part is here. So R square actually varies from 0 to 1. Similarly, adjusted R square also varies from 0 to 1. But yeah, and this is actually main things. Why we generally use adjusted R square instead of R square? The sensitivity to the predictors. So it actually says that if we add a new independent variable in our data sets, then generally R square increased. But if the new independent variable which we try to add is not uh, correlated with our dependent variable, then adjusted R square do not increase as R square increase. So, for that reason, adjusted R square gives us more naturalistic performance metric than R square for the complex cases. So here the advantage of the R square is it's a very simple, and we generally use is for lots of regression models. And adjusted R square is generally we use when our model is more complex. That time we generally use the adjusted R square. And R square actually it gives high accuracy when the model is overfitted, but adjusted R square actually prevent this type of problem. So now we go to the coding part. So as you see here, the standard things, first we uh, put all the necessary library, then we uh, import the data set, and after that we do the 10 test fleet, and then we do the prediction through our model. This will be the flow for this. So here, as you see that we import the two necessary things, that is pandas and numpy, and we take California housing datasets. After make it in data frame, we first we define our user user defined R square, and we try to compare with it our inbuilt R square, which we take from this scalar matrix here, this metric here, as you see. So here, as you see here, the this is user defined R square. How do we calculate? It's actually 1 by sum of square residual by sum of square, where sum of square residual equal to summation of I equal to 1 to n yi minus yi hat. Why we calculate yi hat actually prediction, and sum of total is summation of yi minus yi mean, y mean. Y mean is calculated as sum of y by total number of y. So this is user defined R square, and this R2 score is our inbuilt R2 score. Here we apply it on our linear regression model, which we import from linear model uh, from a scalar library. So first we do the 10 test split, then we feed linear model. Here our aim is to find the R square score and adjusted R square code. So for that reason, we did not do any hyperparameter tuning in the linear regression. So just fit 10 test split, then find the prediction, and we calculate these two things. First R2 by built-in R2 score, and then by user defined R2 score we calculate the R2 user defined as here. Then we calculate also adjusted R2 as the, as you know, the what is the definition was 1 minus 1 1 minus 1 minus R2 into n minus 1 by n minus p minus 1. So return, then we return R2 user defined score and adjusted R2. So when we try to see what's the thing here, so as you see here, R2 score is 0.59. Also our user defined R2 score, which we write from scratch, it's also 0.59, and adjusted R2 is actually 0.59. So this is actually all the procedure how to you calculate this R2 adjusted R2 for for a calculate the accuracy of the performance, or it's a performance matrix of the or some model that is generally linear model. So thank you for attending this uh, lecture. Okay, let you see again. Thanks.